then, here you go, use an arrow, Q, you hit her cat. So this is the symbol that we use for if and connecting. There you go. So this is and, conjunction or disjunction, this is if then. Well, if you interman this office, is antecedent, then you pet her cat. Pet her cat is the consequent. What if I tell you, if you don't interman this office, then you don't need to pet her cat? Well, if I want to use actually symbols to represent that, if you don't interman this office, you interman this office is P. So you don't interman this office, so it's not P. If not P, then you don't pet her cat. Pet her cat is Q. Don't pet her cat is not Q, the negation. So if not P, then not Q. So I changed this statement into symbols. If P then Q, there are different forms actually to express the conditional, like Q if P, or P is sufficient for Q, Q is necessary for P, P only if Q, only if Q, P. So these are different forms of actually expressing that statement, conditional statement. Now, let's say I have this P and Q. P is I will do well on the test tomorrow, and Q is I will study tonight. Okay? I want you to replace P and Q, right? For these statements, represent these statements using symbols. Okay? Well, let's look at them. The first one, A. If I will study tonight, then I will do well on the test tomorrow. If antecedent, I will study tonight. I will study tonight, we are representing that with Q. So if Q, if I study tonight, then I will do well on the test tomorrow. I will do well on the test tomorrow is represented with P. Okay, so the first one, A, is if Q, then P. Look at the second one, B. I will study tonight and, okay, we have conjunction. I will do well on the test tomorrow. I will study tonight, you represent that with Q, Q, and, okay, and I will do well on the test tomorrow. I will do well on the test tomorrow is represented by P. There you go, Q and P. Look at the third one, C. I will not study tonight. I will study tonight is represented by Q. So I will not study tonight, then is the negation, not Q. So here you go. I changed these statements into symbols. Yeah, if Q then P, Q and P, and not Q. Good? Well, we can have biconditional, if and only. What is this? Let's say P is you invest in Widget Incorporated, and Q is you get rich. And I tell you if P then Q. If you invest in Widget Incorporated, then you get rich. When I have this statement, okay, well, if I change the place of P and Q, right? So if you get rich, then you invest in Widget Incorporated. It's not necessarily true. So if I have if P then Q, right? It doesn't mean that if Q then P is necessarily true, right? It doesn't mean that. But let's say you have a case that if P then Q is true, if Q then P is also true, so in that case, we have a biconditional statement. So how we show that is that P if and only if Q Q, this is the symbol that we used, right? In that case, we have a biconditional if and only if. So P, if and only if Q. Biconditional. Here you go. So biconditional, let's go through an example. Let's say a statement P tells you that a triangle is equilateral. Okay, equilateral, it means that, all the sides, are the same. For example, if this is 5 meters, this side is 5 meters, this side is also 5 meters. Okay, so it says that if P says that a triangle is equilateral, and statement Q says that a triangle's angles all measure 60 degrees. It means, for example, you have a triangle, this angle is 60, this one is 60, and this angle is also 60. So P, a triangle is equilateral, Q, a triangle's angles all measure 60. If P, then Q. If a triangle is equilateral, so you have a triangle, equilateral, this is 5 meters, 5 meters, 5 meters. If a triangle is equilateral, then its angles all measure 60. Then this is 60 degrees, this is 60 degrees, and this is 60 degrees. If P, then Q. But as you see in this example, if Q, then P is also true. If all the angles of a triangle measure 60, so it means you have a triangle, right? This angle is 60, this one is 60 degrees, and this one is 60 degrees. If Q, then the triangle is equilateral. It means this side is equal to this one, is equal to this one. For example, if this side is 3 meters, this one is also 3 meters, this one is also 3 meters. So if P, then Q is true, if Q, then P is also true, so we have a biconditional statement. So we say a triangle is equilateral if and only if its angles all measure 60 degrees. And this is how we show that, right? The single if and only if. Biconditional. There are also different ways of actually expressing biconditional, P if and only if Q, or Q if and only if P. So please read that table. Well, what about parentheses? When you have symbolic statements, right? Parentheses, they show you which symbols have been grouped together, okay? So, for example, here, if I have negation, then I have parentheses, P and Q. It means the whole statement P and Q has been negated, right? The negation of the entire statement, okay? So the parentheses show you which symbols have been grouped. Here, P and Q, they have been grouped together, right? Well, this is different from when you have no parentheses. If you have something like that, it means P has been negated, right? Not P and Q, right? So parentheses are very, very important. They tell you which statements are grouped together. So, well, when you have actually a statement, you can use commas to show that which statements have been grouped, okay? Let's look at this example, okay? This is a symbolic statement. I have Q and not P. I have parentheses here. It means these two are grouped together. I have conditional, and then I have not R. So here I have 3 statements. So far we have talked about P and Q, but here we have P, Q, and R, okay? For example, P is I studied tonight, Q is I finished my assignments tonight, R is I'm gonna go out for dinner tonight, okay? P, Q, R, okay? So it said which statements have been grouped together. So we have used parentheses here. So these have been grouped together, Q and not P, okay? So if I want to write down using words how I can say that, I say if Q and not P. Okay, use comma. Whatever you have before comma is one group. Whatever you have after comma is another group. So comma is here. It means Q and not P. Here you go. You're one group, right? So if Q and not P, comma, then not R. Now look at here. I have Q and if not P, then not R. So as you see here, I have the parentheses here, right? So if not P, then not R, they have created one group. So what the statements have been grouped together? These ones. If not P, then not R. If I want to use words, so see, Q, then comma. Whatever you have before comma is one group. Whatever I have after comma is another group, right? So I put the comma here, Q, and if not P, then not R. So be careful about the commas and the parentheses. They show you the groups. When you have comma, whatever before comma is one group. Whatever comes after comma is another group, right? So let's say you have symbolic statements. There is no parentheses. Okay. Well, how can you find out which statements have been grouped together? If you don't have commas, you don't have parentheses. In that case, we should look at the dominance of the connectives. Okay. What it means? Well, biconditional is the most dominant one. Then we have conditional. Then we have and or. They have the same level of dominance. Then we have negation, right? So the statements that they come after and before the most dominant connective, they are grouped together. So in that case, if you don't have commas or you don't have parentheses, you need to see which connective is the most dominant one. So don't worry, I'm going to cover an example. Just like here. Look at the first one. There is no comma, no parentheses, so look at here. I have conditional, I have and I have negation. Okay? Well, conditional and negation, which one is the most dominant one? Okay? I go back to the previous slide one more time. See, biconditional is the most dominant, then conditional, then and or the same, and negation is the least dominant one. Okay? So, here, the most dominant negation and conditional is the conditional. So the most dominant connective is the conditional. It means whatever you have before is one group, whatever you have after the most dominant is another group. So before the most dominant, we have just one statement, so I don't need to put parentheses here, just one, right? After that, I have Q and not R. So Q and not R, they create one group. Okay? So what is the type of statement that is conditional, right? The most dominant one. Look at the second one. I have and conditional negation. Which one is the most dominant one here? Is the conditional. So I have P and Q. I have conditional, not R. So this is the most dominant connective. Whatever you have before the most dominant connective is one group. Whatever you have after is another group. So after I have just one statement, so I don't put parentheses. So most dominant connective is conditional. Well, I group that over there. So what type of statement we have? So we have conditional. Now look at here. I have P, I have if and only if biconditional. I have Q, I have conditional, and I have R. Which one is the most dominant connective? That's a biconditional, right? So whatever I have before the most dominant is one group, so it's just one statement. I don't need to put parentheses. And whatever I have after the most dominant connective is another group, so here. So most dominant is biconditional. These statements are grouped together, right? So the type of the statement that is biconditional, the most dominant one. Look at here. I have P, and I have negation, Q, I have conditional, I have R, or, and S. Okay, I have four statements here, P, Q, R, and S. I have and, I have or, I have negation, and I have conditional. Which one is the most dominant connective? That's the conditional one. Whatever you have before the most dominant connective is one group. Here you go. Whatever you have after is another group. Here you go. So one group that we have is P and not Q. The other group is R or S. So the most dominant is conditional. So the type of statement is conditional. Look at the last one. I have P and Q or R. I have three statements, P, Q, R. I have to connect it and then or. Which one's the most dominant? Well, they have the same level of dominance. Can I decide which ones are group? No, I can't. Right? So that's why parentheses and putting commas are very important, right? Okay. Truth table. Well, we said that when we have a statement, right? Statement or proposition is a declarative statement, sentence that is either true or false, but not both at the same time. So we have true and false. So for example, you have P, right? One statement, we call that P. P can be either true or false, right? We can actually show that in a table. It's like a visual, actually, and visually you can see the truth value of statements, right? So we can use a truth table to show, true, false for one statement. Well, for example, we have P and Q, right? Well, I'm going to go back to this statement, right? The important statement that we have. The statement P and Q is true if both P and Q are true, otherwise P and Q is false. I can actually clarify the meaning of this statement using a truth table. Or for the disjunction, we said that the statement P or Q is true if at least one of the statements P and Q is true, otherwise P or Q is false. I can show that in a table. We call that truth table, right? So, truth table, we can use the truth table to find out whether or not an argument is logically valid. Let's say I give you this argument. If you invest in Widget Incorporated, then you get rich. You didn't invest in Widget Incorporated, therefore you didn't get rich. If I ask you whether or not this argument is logically valid, well, we can follow 4 steps, okay? Step 1. Step 1, break the premises into several statements and use P, Q, and R. What does it mean? Step 1, look at the argument that you have. See how many simple statements you have in the whole argument. When you look at this example, if you invest in Widget Incorporated, then you get rich. You didn't invest, therefore you didn't get rich. I only see 2 simple statements. I can call them P and Q. One of them is you invest in Widget Incorporated. Well, I can call that P. And the other statement that I see is you get rich. I call that Q. That's the first step. So find the simple statements, call them P, Q, R, and so on, right? So I found just 2 simple statements, I call them P and Q. You invest in Widget Incorporated, P, Q, you get rich. Step 2, change the whole argument into symbols. Write the whole arguments using symbols. Look at the first line. If you invest in Widget Incorporated, if P, then you get rich. Then Q. So I changed the first line into symbols. Look at the second one. You didn't invest in Widget Incorporated. You invest in Widget Incorporated is P. You didn't invest, that is the negation, not P. Therefore, when I say therefore, okay, the word therefore, it tells me that now we have a conclusion. So I draw a line, right? Then conclusion, therefore you didn't get rich. I use this symbol, it means I have a conclusion. You get rich is Q, you didn't get rich then is not Q. So I changed the whole argument into symbols. That's step 2. Step 3, okay, one thing about step 2, right? Whatever I have above the line are my premises. So I have 2 premises. Premise 1 is P then Q. The second one is not P. Whatever I have below the line, here, not Q, is my conclusion. So whatever you have above the line are your premises. Below the line is your conclusion, right? Okay, here you go. That's step 2. Step 3, I draw a truth table about the whole argument. And step 4, I make sense of the truth table. I interpret the truth table. What is a truth table? So let's see. Now, let's say I have just one statement P. Okay, P. We said that when you have a statement, right? It can be either true or false. So it's either true or false. That's it, right? But not both at the same time. So statement is either true or false. What about the negation? This is P. If I want to show not P the negation, so if P is true, the negation is false, opposite, right? If your statement is false, then the negation is true, right? So this is the truth table of P and not P. Just like what you see here. So you have a statement, 2 options is either true or false. When your statement is true, the negation is false. When your statement is false, the negation is true. Opposite, truth value. So, well, I talked about just one statement. What if you have 2 statements, P and Q, right? Well, guys, when I have one statement, okay, one statement like P, I have 2 possibilities. It's either true and false. When I have 2 statements like P and Q, I have 4 possibilities, okay? So, one statement like P, I have 2 possibilities. Is either true or false. If I have 2 statements, I have 4 possibilities. Why? Let's see. So, let's say I have P and Q. 2 statements. Okay? This is P, this is Q. We have 4 possibilities when you have 2 statements. Well, 4 possibilities. For half of that, which means 2, your P is true. For half of that, 2 is false. So you have 4 possibilities. For half of the possibilities, P is true. For half of the possibilities, P is false. Let's just focus on the case that P is true. When your P is true, you only have 2 options for Q. It's either true or false. Now let's focus on the case that P is false. When P is false, you have only 2 options for Q. It's either true or false. Okay, as you see now I have 1, 2, 3, 4 possibilities. True, 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 false, false, true, false, false. So P is true, Q is true, true, true. True, false, false, true, false, false. 4 possibilities. Here you go. And this is a truth table for P and Q. True, 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 false, false, true, false, false. Well, I have 1 statement, I have 2 possibilities. 2 statements, I have 4 possibilities. What if I have 3 statements? For example, I have P, Q, and R. Wait a minute. What's happening? 2 is 2 to the power of 1. 2 to the power of 2. 2 to the power of 3. So we have 2 to the power of n. N is the number of statements that you have. If you have one statement, 2 to 1 is 2. You have 2 possibilities. If you have 2 statements, n is 2. 2 to 2 is 4. You have 4 possibilities. If you have 3 statements, 3. 2 to 3 is 8. You have 8 possibilities, and so on, right? Okay. So, truth table for P and Q. Negation, we talk about that. You have one statement, you have 2 possibilities, either true or false. One statement and its negation, they always have opposite truth values, right? If your statement is true, its negation is false. If your statement is false, the negation is true. That's about the negation. Well, let's say I have P and Q, just like here, 4 possibilities, and I want to show not P, the negation. So just look at here, right? So I have PQ, 4 possibilities. I have P. I want to show the truth value of not P. So we say that one statement and its negation, they have opposite truth values. So if your P is true, not P is false. P is true, not P is false. The opposite. P is false, not P is true. P is false, not P is true. Right? What about and? Conjunction. P and Q. Truth table for conjunction. Okay. Well, I'm going to go back to that very, very important statement that we wrote on the blackboard. P and Q is true if both P and Q are true. Otherwise, P and Q is false. Okay? Well, I'm going to show you how I can use this statement to build up the truth table for P and Q. So I have P and Q, 2 statements. P, Q. I have 2 statements, so I have 4 possibilities. For half of them, P is true. For half of them, P is false. When P is true, just focus on that, you have 2 options for Q, is either true or false. When P is false, you have 2 options for Q, is either true or false. So we have true, 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 false, false, true, false, false. 1, 2, 3, 4, 4 possibilities. Okay. I want to show P and Q. P and Q. The statement P and Q is true if both P and Q are true. Otherwise, P and Q is false. So this is true when both P and Q are true. So look at here. P is true, Q is true. Both are true. So what do I have then? True. Both must be true to have a true value. Otherwise, it's false. Okay, one is false. We must have both true to have true. One is false, so I get false. One is false, I get false. Both are false, so I get a false. See? So the statement P and Q is true when both the statements P and Q are true. Otherwise, it's false. So that's a big of that important statement that we wrote on the blackboard, right? I'm showing that in a truth table. So this is the truth table for conjunction, for and. P and Q is true when both P and Q are true. Otherwise, it's false. So, what does it mean? P and Q is true if both P and Q are true, otherwise it's false. Well, let's say P is like it's sunny and Q is John is working, right? It's sunny and John is working is P and Q, right? It's sunny and John is working. If it's sunny is true and John is working is true, then it's sunny and John is working is true, right? But if it's true, you know, it's sunny, but John is not working, right? So it's false. If it's not sunny and John is working, it's false.